Here we will differentiate y equals the cubed root of sine x cosine x using U-substitution. So the first step is to identify what u is going to be, and that's going to be the interior function. That's sine of x times the cosine of x. Now the differential is going to get a little hairy because this is a product, so we'll have to use the product rule. So sine times cosine, the product rule says 1d2 plus 2d1. So my first function is sine times the derivative of cosine, which is negative sine. 1d2 plus 2 cosine d1, which will, derivative of sine is another cosine. And we finish up with our little dx at the end. I should probably clean this up a little bit. Since I have sine times negative sine, that'd be negative sine squared. Plus cosine times cosine is cosine squared, with my dx at the end. And we could, switch the order of addition there and just call it cosine squared minus sine squared times dx. Then, this is what we'll use for our U-substitution. Going back to the original function, I want to rewrite that in terms of u. So instead of the cubed root of sine times cosine, I'm going to have the cubed root of u. And it may even be a little bit easier to view this as a power, as u to the 1/3 power, instead of the cubed root. Then when I take the differential of y, I just use the power rule of 1/3 u to the negative 2/3 du. And we can substitute all of our u stuff back in. So dy is going to be 1/3 of u, that is what sine times cosine is, to the negative 2/3 power, times du, cosine squared minus sine squared dx. Our last step is to divide both sides by the dx. Get that to cancel. And we'll want to clean it up just a little bit. So we'll have dy dx. And on the right side, I see that I do have some fractions and some negative powers. So I'm just going to write this all as a fraction. From the 1/3, that means the 3 will be in the denominator. Since sine times cosine has a negative power, we'll put that in the denominator. Sine x times cosine x. And now it'll be to the positive 2/3 power. And that cosine squared minus sine squared, that'll just stay in the numerator. And here is our derivative then.